Real quick before we show you this video on balancing this rotating assembly for a Coyote, it's wanted to touch on a couple things. This is pretty much applicable to any V8. The one thing you notice that's different or that might be odd is that I don't have a flywheel or a harmonic balancer on this. The reason I do that is we will balance the crankshaft by itself, and then we will balance the flywheel by itself and the balancer by itself in an internally balanced rotating assembly environment. The reason that is if down the road you need to change the flywheel or you need to change the harmonic balancer, that the crankshaft is still balanced and you can replace those components with a balanced component and the assembly remains balanced. In an externally balanced environment like a 28 ounce or a 50 ounce small block Ford, you would have to balance it with the flex plate, flywheel, whichever, and the harmonic balancer on it. But normally, internally balanced stuff, we balance those components separately and balance the crankshaft as you see in this video. Hope you guys enjoy the video. Here we go. Hey everyone. Wanted to run through the balancing operations of this is a V8, this is a Coyote specifically. We got a new crankshaft, a set of Manley rods, Manley pistons. It is the Manley H-tough rods, and a set of their extreme duty pistons, which is it's not a strut style, it's a barrel style piston with an upgraded pin. These pistons are uncoated. The reason that is their manufacturing is a bit behind due to the COVID-19 stuff, and it was another 5-week wait time to get the pistons coated. So I'm going to unbox these and show you what's in the box and go through some of the balancing procedures. Here's the part number on this guy. This is a 3 3/4 dome. It's like a standard compression ratio, which in the Coyote's 11:1. So this is what you typically get in a box of new pistons, specifically from Manley. Not everybody does this. They're kind of in a cube box. A lot of them are like rectangular and the pistons are laid out differently, but these are all wrapped in just in a paper and like a shipping paper. Pins are in these boxes. The clips are, here's the wire locks. Can't really see them on the camera. But I'm gonna get these unboxed and then I will talk you through what I do in the beginning procedures of balancing the pistons first. So. Alright, now that I've got these all unboxed, the first thing I'm going to do, well, a couple things noted quick. I keep all the papers and the pin wrappers. The reason that I keep those out currently is so that when I'm done balancing these, I can put the pins back in the wrappers and the pistons back in the wrappers and back in the box so they're safely stored until the engine is ready to be assembled. Honestly, the next step would be to mic all these for bore size, put them in their particular cylinders. I do that just before hanging the pistons, and then I will label them at that point. So for this video, we're not going to cover any of that. We're just covering the balancing procedure. So the next thing I'm going to do is I'm going to weigh all of these pistons individually, and then I'm going to write on the piston which one is the lightest, which one is the heaviest. Then I'm going to do the same with all the pins, and I'm going to put the heaviest pin in the lightest piston and so forth to try to get these all to the same average number. We'll see how close they are at that point and if we need to remove any weight. Everybody's got their own tolerance for what's acceptable here. I try to get everything within 0.5 gram. Sometimes that's not attainable. Typically it is though. So I'm gonna start weighing this stuff and go from there. Alright, now that they're all weighed and the pins are all matched with the pistons, we've got a spread of 1.1 grams from lightest to smallest. What I'm going to do next to make these closer to the same wait is I'm going to take a sand roll on my die grinder and trim stuff up a bit. Usually I do, oh sorry, these edges here, especially when they're this close, like, you know, a lot of them I won't touch. Like I said, my tolerance is 1/2 gram is what I'm happy with. So, you know, there's, this one's half, that one's 0.3, 0.4, you know, so at least half of them are already within tolerance. So I'm gonna run through that process quick and show you guys how I do that. Okay, I got these all cut. They're within 1/2 gram. I think right at 1/2 gram. A couple of them I think are 0.5, but you know, that's fine. Most people would tell you that I'm crazy for trying to get them that close, I feel. To give you a better idea of what I'm doing with the sand roll there, I'm just rolling that edge, cut these corners back a touch. You know, obviously these are a nice piece. I've seen some pistons for, like, you know, your Ford 100 bore or whatever, like Seal Power OEM replacements like Oldsmobile, Big Block Chevy, whatever, the inexpensive stuff. I'm not kidding you, be 3 or 4 grams off, and that is a disaster to cut material out of. So I've put them in the lathe and cut this pad down before. You know, generally anything using that piston is pretty low power, so you have a little bit of leeway on what you can do. Obviously, I've been doing this for years, so I use my best judgment. I don't recommend anybody just go in here and start cutting stuff, you know, because you can cut the wrong spot. You can make the piston weaker. I've never had a failure from that, but it is, I'm sure, possible. So now I'm going to package these things all back up, and then we're going to start working on the connecting rods. All right, now that the pistons are done, let's work on the connecting rods here. This is the part number. This is an H-tough rod from Manley, which has the, it's a thicker cross-sectional area of the beam. I'll show you a picture of that, I think, in a second here. I think this one of these opened. They all come in this, you know, this plastic bag. It's got an oil in them to keep, obviously, prevent them from rusting. You can see, I don't know if you can see the oil in the camera, but so yeah, see how thick the cross-sectional area is here. They've machined, you know, or put a little bit more material around the pin end. This is an ARP 2000 bolt piece. So first thing I'm going to do, oh, actually, before I forget, check out so they weigh these, so you kind of know what you're working with right out of the box. I mean, right there's 219.6, 218.3, you know, 1.3 grams there already. So, you know, my tolerance again is a little tight, and I think that it's tighter than it needs to be, but I know that I can control how tight I balance these things. Whereas in the engine with oil moving around, there's a lot of things you can't control. So the things I can control, I'm going to get as close as I possibly can. Takes me a little bit more time, costs my customers a little bit more money, but in the end, I know that it's, you know, the best thing I could make. So the first thing we're going to do, we're going to unbox all of these. I'm going to rinse them all off in our just our mineral spirits tank to get all the oil residue off of them. I have to set up a balancing jig, which I will I'll show you, talk to you about what the purpose is of that when we get to that point. All right, I got these rods all cleaned up. You can see they don't look near as pretty after I've washed them in solvent. There's a bit of the white residue from the mineral spirits. It's a pretty fresh mineral spirits batch. When you get some oil in it, it tends to not do that. But okay, so here's the balancing rig. This is how we balance connecting rods. This allows us to balance the small end and then the big end. So this here, which I haven't set this up yet, so kind of bear with me, but this here will fit in the inside of the connecting rod. That allows us to keep, when set up ideally, obviously I have to move these, those two pins would be on the same height, basically making the connecting rod level. you can tear the scale so that the scale would be 0 with this hanging on it, so you're only balancing, in this case, the big end of the connecting rod. And then that will basically allow us to dynamically balance end for end the connecting rod. Again, dynamically, not just overall weight of the rod, but each end of the connecting rod individually. So how I do that, how I balance it, once I get this set up here, tear it, I'll go through and weigh all the connecting rods. So I have the lightest weight rod in here. I set that one aside to allow myself to double check that the scale hasn't wandered a little bit. It does tend to move. It is pretty accurate down to 1/10 of a gram. So it does change a touch. Then what we'll do on the big end is I'll remove material from this side of the rod bolt. I do that on my belt sander, which if you're wondering why I have a belt sander in here, that would be why. Just, you know, roll it like this, flip it over, same on the other side, same on the other side of this thing. Obviously I try to keep it, you know, I try to take the same amount of material from each end. On the small end, I'll take this like this, roll it upward, flip it over, do the same thing to remove material. Obviously when balancing the small end of the connecting rod, I move this puck from here to this side, and that will allow us to just weigh the small end of the connecting rod. Same procedure, measure all of them, see which one is the lightest, make sure that's teared in there, set the lightest one aside to allow you to double check it, and then run through the process of balancing the small end of the connecting rods. So I'm going to set the camera aside and get moving on that. All right, now that I've got the connecting rods balanced and boxed back up, the next thing we need to do is we weigh the round wire locks, see in there, and we weigh the ring set here, and we also weigh 2 pairs of connecting rod bearings. These are weights that are required for the calculation of the bob weight, which the bob weight, obviously used to simulate the rotating assembly on the crankshaft, allows me to balance the crankshaft on our balancing machine. So I'm going to get those weights and start working on the bob weights. Okay, got everything weighed and the bob weight calculations all figured. So I wanted to show you guys what we use for a bob weight. There are several different designs. This stuff's kind of old, but it works really well. I'm able to get really accurate with it. So here's how I set up a bob weight. This is half of a bob weight. And then this is the cap that holds in there. This holds a lead shot. To give you an idea what it looks like. It's like legit just small lead BBs. So there's a nut in the cap that hold this half together, so I'm weighing the entire half, and then we weigh them, you know, halves, put them together, weigh them again, confirm the data is all correct, and then there's 4 in this situation. Being a V8, there's 1 for each rod throw. Giving you an idea how sensitive this is, so it's 11, sorry about the light, 1120.1 grams, right? I'm gonna put 2 of these little BBs in here that you legit can't see, just to show you how close I can get it. Oops, I bumped it. Let's let it settle. Dropped 1 in, dropped another 1 in. See, it moved 0.2 of a gram. It took it a second, but right on the verge there. But to give you an idea how sensitive these things are and why I'm pretty careful to get stuff as close as possible, because this allows us to. So I'm gonna go ahead and fill all these bob weights up, set them up, and get them ready to go on the crankshaft. I got the bob weights all made up, so let's get this crankshaft open. Show you guys this new Coyote crank here. It's a nice piece. So the next step is to get this crankshaft on the balancer set up centered, and then we will hang the bob weights on it, spin it, see what the balance is currently. Typically, I know the factory bob weight is pretty light with this H-Tough rod and the thick pin. We've added a bit of weight to the bob weight. I'm anticipating having to add some heavy metal to the counterweights on both sides to get it to balance. But we'll get it on the balancer and spin this thing up and see how far off it is and make a plan from there. All right, now we got the crank up here, all the bob weights on it. I've spun it for the first time. I want to give you guys an idea of what this balancer looks like. This is a Heinz. It's pretty old, a bit older, but it still works, does what we need. You'll see on here there's a degree wheel to use for reference on where to remove the weight. Right now it's asking you to move 64 grams from this location and 57 grams from this location. Obviously there is not 60 grams worth of material to be removed there. What that means is we need to add heavy metal weight to the opposite of that to make this side heavier, so it's going to next time hopefully tell us to remove weight from here. And how we're going to do that, I have a jig to put the crankshaft in. I will drill into the side of the counterweight. We'll press in some heavy metal. In this case I believe this is tungsten, and then I will I TIG the weights in. They're obviously they have a little bit of press, and then I TIG them in using like a brazing rod. So I'm going to move forward with that. I'm probably not going to do a video with that just because it's pretty time consuming. So we're gonna get I'll get weights, but I'll get weights put in both sides of these things if I remember how to talk, and then I'll come back and show you a video. So this is what the counterweight looks like now, and then I'll show you an after with the heavy metal in it so you can see what I did, and then we'll continue balancing the crankshaft. Okay, she's all wrapped up now. I wanted to show you guys where I put the weights. You can see it in there in a little discoloration, but they're TIG welded up. I put a big bevel on them so I can cut, make them back flat, flush with the counterweight. I'll show you the front one. You might be able to see a little bit of color difference from the filler rod and that guy there. Actually ended up having to drill that one just a touch, but that's pretty much it. So we use, the heavy metal to offset the counterweight to get it close. And then I'll use a couple different drill sizes and honestly a hand grinder to finish it up. You can see a lot of the work I did on the end of this counterweight and on the end of this one as well. I'll go back through with an SOS pad and just kind of buff the thing a bit to make it look, make it look a little bit better. Not that it really matters, but right now it is 0.3 and 0. That's tenths of a gram, so she's pretty much as good as you can get. I bet if I spun this thing again right now, those numbers would change. That's how close it is, which is pretty normal. Takes some time to get there, obviously, having to add the heavy metal, and then just the time frame it takes to continually move weight here and there to get it down to those numbers. But that's it. So this thing will get, I'll pull the counterweights off of it, we'll clean it up, run it, we'll polish it quick, put it in the bag, put it back in the box, and then it is ready to be assembled. But for now, that's all for the video. Please subscribe to the rest of our stuff. I might do a build video on this engine. I haven't 100% decided if I want to go through all the processes on this one, but I might. So subscribe, and if nothing else, we'll keep these kind of videos coming and our dyno reviews as well. Thanks for watching.